Everyone, today we are going to discuss the topic of inverse Laplace transform. So we will see how to find inverse Laplace transform of any function. So first of all, let's define it. So if the Laplace transform of any function of t is defined as a function of s, then we define the inverse Laplace transform as Laplace inverse of f of s as f of t. Means we just take this operator L on the other side and we denote it by L minus 1. So what is actually happening? When we take the Laplace transform on a function of t, we apply the Laplace transform operator, get a function of t. Now if we return back to the original function, we will be from the function of s, we will apply the operator Laplace inverse. Okay, so here we are going to use the same rules of Laplace transform. So what we did when we were using it for Laplace transform, we were looking at the rows, the numbers in the first column and the corresponding Laplace transform in second column. But when we are doing the inverse Laplace transform, we start with the function in the second column and then the corresponding answer in the first column. So for inverse Laplace transform, we follow the table from right to left. Like first rule, what we studied, the Laplace transform of C is C over S. Now what we are going to study when we are going to use it for inverse Laplace transform, we say that Laplace inverse of C over S is C. So for example, if we have to find Laplace inverse of 3 over S, so what this rule becomes, the first rule, this rule will be like Laplace inverse of C over S is C, constant over S is C. So as per this, it will give you 3 over S, 3 is a constant, gives you 3. Next, Laplace inverse of 1 over s plus something. So s plus 7, which is equivalent to this rule, rule number 2. So this rule is Laplace inverse of 1 over s plus a is e power minus at. So here it is plus a, you are getting minus a. So it is plus 7, you will get e power minus 7t. Next, Laplace inverse of 4 over s square plus 16. You know that 16 is 4 power 2. Okay. So if we look at this, these two rules are matching. But in the numerator we have 4, a number. Here we don't have a number. In sign rule we have number. So we are going to use this rule which says that Laplace inverse of a number over a square plus the square of the same number is sine at. So we are using this rule from here to here. So this gives you sine 4t. So we should see that if it is 4 square, we should have 4 here. If it is some other number, we need to modify it. Similarly, if it is 3 factorial over s to the power 4, it is matching to this rule. So if it is n plus 1, we should have n factorial. So here n plus 1 is 4 and we have 3 factorial 4 minus 1. So it gives you t power 3. Okay. So let's solve these questions. Laplace inverse of 1 over s minus 2. So what rule we studied before? Laplace inverse of 1 over s plus a is e power minus at. So if it is plus a, we are getting minus a. So it is minus 2, so we should get e power, the number remains same, we change the sign to plus t. Okay, now here s over s square plus 25. So 25 we can write it as 5 to the power 2. Now what you can see here, you have s. So in this one, now we are going to use the rule for cosine because it is having s in the numerator. So it will give you cosine 5t. Now for 4 over s, again 4 is a constant, this gives you 4. 12 over s square minus 9. So we know the rule that Laplace inverse of a over s square minus a square is sin h at, right? Now, so what is the requirement? If it is a, you should have a in the numerator. So what is here? We have 9. So 9 we can write 3 power 2. But here we have 12. So what we will do? We will write it as Laplace inverse of. Can we write 12 as a multiple of 3? Yes, we can write 3 times 4 over s square minus 3 square. Okay. So this gives you, now we don't need 4, we need only 3. So this 4 we take outside and we can write it as 3 over s square minus 3 square. So for this, now we will make use of this rule. So this gives you 4 sin h of 3t. Okay, so we have this answer. Okay. In the same way, we can work with some more examples. Say, if you need to find Laplace inverse of, say, 2 over s square plus 9. So you have 2 here. Okay, so first you have to check a number divide by s square plus something. So 9 you can write 3 square. So you need to look for the rule matching to it. So the matching rule is Laplace inverse of a over a square plus a square, which gives you sin at. Now, what is the requirement of the rule? If you have a square here, you should have a here. But you are having 2, which is not 3. With so to apply this rule, if it is n plus 1 here, n plus 1, we need n factorial. So if it is 10 plus 1, so we need here 9 factorial. Sorry, if it is 10, 10 we can write as 9 plus 1. So we need 9 factorial here. So we multiply by 9 factorial and divide by 9 factorial as we did in this example. So this now gives you 6 over 9 factorial, and Laplace inverse of 9 factorial over s power 10. Making use of this rule gives you t power n, where n is 9. So it gives you t power 9, which is same as if we use this rule and get the direct answer. So if we work in this way, it will be much easier. Like say if you have example of say Laplace inverse of say anything 2 over s power 8. So we know that we don't need to take it outside. S power 8. So n plus 1 is 8, gives you n is equal to 7. Use this formula. So n is equal to 7. It means you need t power 7. T power 7. So divide by 7 factorial. So if you do it in this way, it will be much easy. Now what you can see that whenever we apply inverse Laplace operator to any function of t, any function of s, the answer should be in terms of t, a function of t. There should not be any s term. No s term, because if you are getting any s term, it means you made a mistake somewhere. See, all the answers. No s.